This case is the Lian Li 011 Dynamic Evo, or the Evo, to make life easier on my pronunciation. It's a case that I reviewed very recently. The review went to 32 minutes in length. I love the case to pieces. Thoroughly recommend that you buy it if you can find it in stock, probably in middle January at the earliest. My problem as a reviewer is that every other reviewer also loves the Evo, and this was plain and apparent just as soon as I unboxed it and got my hands on it. It's obviously a good product. My review took as long as it did because Lian Li sent me all 5 of the accessories that come with it: the vertical GPU, upright GPU, the top I/O mounting, the alternate I/O, and the front mesh panel. Therefore I went on at some length, but I still didn't cover a fraction of the permutations that you can look at with this case. For example, liquid cooling. So it's time for some custom loop goodness. I've got 2 ways I can go with this. I can go down the AMD route or the Intel route. These 2 motherboards come from MSI and they are the EK variants. They're both carbons, as you can see, X570S and Z690 for Intel Alder Lake. But as you will have seen in the review I just did of the Evo, I used a Gigabyte Aorus master motherboard with a Z690 chipset and a Core i9 processor. So we've done that one, which means that we can now look at AMD with some liquid cooling in the Evo. As you can see, I've already offered up some liquid cooling hardware, which I think will work. Not absolutely certain yet. I haven't put the MSI EK motherboard in place. I'm feeling reasonably confident. Let me show you what I've done. Front I/O panel is on the top using that accessory kit, and obviously you saw the mesh front panel accessory. We have a total of 10 Noctua Chromax fans installed, 3 under this AlphaCool 360mm copper radiator, 3 freestanding at the front, 2 above this 240mm AlphaCool crossflow radiator, 1 at the rear, and 1 hiding around the back of this EK Quantum Kinetic flat reservoir. It's a 240mm reservoir with a D5 pump at the bottom. Let us take a look at the MSI MPG X570S, the S suffix significant, carbon EKX. Luke has talked about the X570S. It is the same chipset as the AMD X570. However, the manufacturers have made the motherboards so they have passive cooling on the chipsets rather than those irritating little fans that we are so used to seeing on AMD AM4 motherboards. Take all the bits and pieces out. That's one of those little bicycle pump type pressure testers that EK sells for about £30 US from memory. Then we have the motherboard itself, which is a standard MSI X570 carbon motherboard, but you don't get the VRM heatsinks. You do, however, get the monoblock from EK, which will cool both the CPU and the VRMs. Goes like so, and obviously is aesthetically matched with the motherboard. So the monoblock will cost you about £100 US. The motherboard itself is mid-range to higher end. The package as a result is quite expensive. You essentially get the pressure tester for free. This MPG X570S Carbon EKX motherboard, the name doesn't tell you everything you need to know. It's actually based on the MPG X570S Carbon Max Wi-Fi from MSI rather than the previous X570 Gaming Pro Carbon. And there are some differences. This board has 4 M.2s under these heat shields, whereas the previous Carbon had 2. It has a full complement of 8 SATA rather than 6, should you care about such things, and it has this extensive heat sinkery, which means that the chipset is passively cooled. Let's take off the M.2 heat sinks quickly and have a quick look. Quite like the fact these heat sinks are separated 1, 2, 3 and 4. It means you don't have to strip the entire board to get to an individual M.2. hefty great big thermal pad on the chipset. Another big change from the original Carbon is that that had 10+2 VRM stages, which apparently were 56 amps. That's an extraordinary number. This Max has 14+2 stages, or 7+1 doubled, 75 amps a piece, plenty of power. The rear I/O panel is slightly curious because it includes a PS2 and also an HDMI. This board supports APUs. The odds that someone's going to put an APU in here and use integrated graphics strikes me as unlikely, and if you're doing testing to confirm whether your processor or your board has problems, you're not going to want to remove a monoblock to get to the processor socket, swap it for an APU and put it back together again. Bit surprising that. So the HDMI and the PS2, they seem misplaced. The board itself, on the other hand, absolutely fine. We install the processor in the AM4 socket, backplate goes on, thermal pads on the monoblock, TIM on the processor, and install it on the motherboard. Let's get this PC together. Brand new AMD Ryzen 9 5950X. How do I know it's brand new? I bought the thing. Storage, a Sabrent Rocket 4 Plus. That's the newer, faster controller. It's a mighty 2 terabytes in capacity. The procedure is to take the 1mm thermal pads. Not quite sure why they've supplied both 1.5 and 1mm. Put those to one side. Apply these to the VRMs. The next step is to apply thermal compound to the CPU. Then we slip the monoblock into place, flip the board over, install the insulator piece and the backplate, and then we use the supplied screws to fasten the monoblock securely in place. That's the monoblock installed. I haven't mentioned that it contains a little impeller so you can see coolant flowing, which is a nice touch. That's the motherboard assembly ready to go in the case. I've been busy installing hardware. The motherboard assembly is now installed along with some G.Skill Trident Z Neo memory. And around the back we have a Seasonic Prime Platinum 1300 watt power supply, and we also have an EK Loop Connect fan and RGB controller hub, which is currently, I believe, not on sale at EK. They've had software problems, but I'm determined to give it a try. So I've got so many fans to control that one of these gizmos could be the answer to my problem of not having enough fan headers on the motherboard. Graphics card RTX 2080 with an EK Quantum Vector block and backplate. Now clearly I can install the graphics card horizontally without any difficulty whatsoever, and it'll look perfectly decent. I would like to install the graphics card vertically because this aesthetic matches the monoblock absolutely perfectly. The snag is if I use the Lian Li vertical GPU accessory kit, the radiator at the bottom takes up space I require, so this combination of radiator and fans in the floor of the case isn't going to work with this vertical GPU kit. So the smart move is to take out this assembly, take out the front fans, swap the rad over, and see if everything then goes nicely into place. After a couple of experiments, I've removed the 360mm radiator entirely. We have the 240 crossflow at the top, a 240 at the front, and now the vertical graphics mount is looking good. In with the graphics card. It looks like the fasteners for the graphics card are pretty much supporting the bracket rather than the other way around. That's more like it. As I was assembling the loop with this ZMT tubing from EK, I realised I'd mucked up the front royally, so I've now reversed the 240mm rad at the front and I've taken out one of the fans. We have some EK Cryofuel solid white coolant. Let's see what happens. In case you were wondering, that was a completely faked moment of jeopardy there, because EK includes their leak tester with the motherboard from MSI. This is my own leak tester, which of course I had previously used to confirm the loop wasn't going to do anything horrible when I hit the switch on camera. The cooling system has bled, I've topped it up again, and the PC is now up and running. I noticed initially one or two of the fans weren't actually rotating because I hadn't made proper connections with those cables. Whoops. But now it's all good. It's a fully functioning PC. I'm going to have a little play just to check performance, and then I'll give you my conclusions on the Lian Li 011 Dynamic Evo with a full custom loop system installed. I've switched the RGB lighting from steady white to rotating RGB, and it looks perfectly pleasant. It's also worth noting that the I/O shield on the motherboard, for some reason, 2 of the 3 lights are stuck on red, so that's not good. However, the overall effect, thumbs up. While I was working on my thermal test results, some Christmas gifts arrived from EK, including this EK squeezy ball tension thing love heart. I'm not saying it influenced me in the slightest, but it's hard to resist. The important thing to remember here is that I am not comparing custom loop in the Evo with AIO in the Evo, because the 2 test setups I've used have been completely different. Mainly it's for your interest, because just switching the cooling system with the same core hardware, it's scientifically useful, but it gets a bit dull. Let's remind ourselves of my previous test results with the Intel Core i9-12900K on Corsair all-in-one liquid cooler and an air-cooled Sapphire RX 6800 XT. We're looking at the 2 test results I got with the mesh front panel. We're completely ignoring the glass front panel, so we're going for maximum airflow. And if you recall, I used 2 sets of fan speeds. However, the thermal results were very similar. We're talking here, of course, about a very hot and juicy processor. Total system power draw in this configuration, 620 watts at the wall socket. For my first test with the custom loop, I ran the Ryzen 9 5950X on auto, so that's 4 GHz all cores under load, all 9 Noctua fans locked to 1000 RPM, and it sounded like this. Temperatures looking good, processor at 65, graphics at 55. However, I want to reiterate, you cannot compare this setup with the previous Intel AMD graphics setup. That's just to give you an indication of where a regular high-end PC is going to operate in this case. Custom loop is a completely different animal, regardless of the hardware. For my second test run with custom loop, I enabled PBO on the processor. That's an easy flick of the switch in the BIOS. And now the processor was running at 4.25 GHz all cores. Power draw for the processor has now risen from just under 140 watts, it's 138, 139, and it's just over 200 watts now, 203 watts. So that extra 200 MHz, 250 MHz of clock speed requires a huge percentage of extra power draw. The fans are actually running slightly faster in this configuration, 1100 RPM. The fan curve wasn't quite flat and the temperatures have been driven up significantly. However, by ear, you cannot tell the difference between 1000 RPM and 1100 RPM in this case. The graphics card temperature, as you can see, has barely changed. CPU temperature has jumped by best part of 20 degrees Celsius. That extra power is making significant demands on the cooling system. For the third test run with custom loop, I left PBO enabled on the processor and increased the fan speed to 2000 RPM, and it sounded like this. You can see that the increased fan speed has helped temperatures. It has made very little difference to graphics temperature. The process has come out slightly better. And that's telling me two things. One is that this case responds to better airflow with increased fan speed, just as you'd expect. The other thing is, I'm quite sure this system could use more radiator area. Two 240mm radiators is not really providing a huge amount of cooling. If I was to reconfigure the system and use 280s or 360s, I'm absolutely certain it would help CPU temperatures significantly. Here's what I've learned from my second look at the Lian Li 11 Dynamic Evo. In my original review, I raved about this case and I'm sticking to that. It's a thoroughly good case and good value for money. A few people commented, depending on how many accessories you buy, of course, the price of the case can move around quite dramatically. My recommendation is that you get the case with the front mesh panel. Apart from the fact it's mesh, it also means you can add more fans at the front should you wish. I personally would go for the top mounted front I/O. If you're going to have your case on your desk, you might be perfectly happy having the I/O down low. For me, on top makes sense. I think I'm disinclined to go down the vertical graphics route because it means putting a radiator on the floor of the case is slightly more problematic. I think a horizontal graphics card in this PC would work very well. But I could be persuaded. In terms of cost, the vertical bracket and riser adds a decent amount of money. If you go for that upright GPU, which I do not recommend, that adds even more. The second I/O, not for me, thanks. So front mesh for sure. That's a very good way to go. I like how this case looks. I like how it performs. You need to run your fans as low and slow as you can. With this much mesh, it's just noisy if you crank up the fans. And you want decent quality fans. These Noctuas are mind-blowingly good. The EK flat reservoir I've put in the side location with the pump on the back. I think it looks lovely. Really smart piece of work. However, it's taking up a position that could be occupied by a radiator. If I'd gone for a conventional tube pump res unit, which I could have mounted on a rad, I could have put a 360 radiator in the side, perhaps with a pump res on that, perhaps with a pump res on the front. I'd have loads of permutations and options. However, as we've established, if you don't enable PBO on this mighty 16-core processor, despite the fact it's got a fairly decent graphics card in the loop, temperatures, no trouble whatsoever. My takeaway is the Lian Li 11 Dynamic works brilliantly well with an AIO, and it works fabulously with custom loop cooling as well.